Hi guys, this is the Innovative Minds Tutor. In this lesson, we are going to work with quadratic inequalities. Right, quadratic inequalities. Without wasting time, let's put this into practice. Well, first thing first, guys, let me take you to the steps that are required here. First thing first, you factorize. If it's factorized, you factorize. If it's factorized, you just work out the critical values. Then third step will be number line. You're going to work with number line. The fourth step will be test your solutions, right? Okay, let's put this into practice. This is not in a standard form. We need to rearrange it in a standard form. Yes, of a quadratic equation. Take 12 to the left hand side. It changes the sign. It will be x squared minus x minus, since it's positive, it will be minus 12, less than or equal to 0. Then we follow our first step. We said is what? We need to factorize. Then what are the factors of x squared? The factors of x squared is x and x. What are the factors of 12? Oh, definitely the factors of 12, it's 4 and 3. Meaning that when we add them, we must get negative 1. Meaning that 4 must have a negative sign for us to give us negative 1. It will be negative 4 plus 3, which will give you negative 1. So in this case, we can put minus 4 here, and we put minus 3 here. I mean, we put positive 3 in this case. Remember, the last sign tells you if it's negative, it means the sign will be different. If it's positive, it means that the sign will be the same. Be very careful in terms of the signs. So it's going to be less than or equal to 0. So in this case, we are going to have plus 3. Then what is the third step? Number line. Put this in a number line. Represent this in a number line. We are going to put what? The critical values. Guys, what are the critical values? Critical values are values of the variable that will make the inequality equal to 0, or the denominator of inequality equal to 0. So that's that's what we call critical values. So you're going to place your negative 3 here, as well as your 4. Then the fourth step will be to test the solutions. How do we test the solutions? Remember, we need to take note of this. This side, this left hand side, it's negative. It's less than 0. It's negative, meaning the product of these vectors are negative, must be negative. How do we test that? There are 3 regions that must satisfy that part. We could call this region A, region B, and region C. So how do we prove that? Remember that this side undergoes negative infinity and this side undergoes positive infinity. So we are going to look at the values that undergo that are between 4 and infinity. Definitely that will be 5. Let's try using 5. If we say 5 minus 4 as well as 5 plus 3, we are going to get positive 8, meaning that this side is going to be positive. So what about this region P? We are going to look at the values that are between negative 3 and 4. So let's plug in where there's x, let's plug in 0 then. We are going to plug 0. If we plug 0, we are getting negative 12, meaning that this side it's negative. So let's plug the values that are between negative infinity and negative 3. Let's try to plug negative 4. When we plug negative 4, you can plug any values there that are undergoing this region. So let's see. If we plug negative 4, what are we getting there? We're getting positive 8, meaning that this side is going to be positive. So now, lastly, we have to write this in an inequality. We have to represent the solution in an equality sign, in inequality form. How do we do that? We are going to say, since our value is here, this side it's negative. So let's see how are we going to prove this. What happens to this side? This side is undergoing a positive side, meaning it's getting greater. So it's going to be a negative 3. It's greater or equal to x, but less than or equal to 4. Is it 4? Yes. This will be the solution. Or you can use an interval notation. Guys, let's not forget here, we are going to use closed circles. Then let's join this. Yes, if it will be like this, we'll connect these two dots. So that's how the first equation, the solution will be like this. That's how you can solve your inequality in this manner, right? Let's go to the second question. So the second question, the values, the factors, this equation is already factorized. So what we are going to look at, it's the critical values, CV. So x will be, when you equate this everything to 0, it will be -2. This will be positive 5, right? So remember that our second step is to do what? Is to plug, third step is to plug the number line. Is to plug the critical values on the number line. Sorry for that. So here at the left hand side, we're going to put -2 and 5. Remember, it's going negative infinity. And here it undergoes positive infinity. So here we are going to look at the product of these factors that are positive. Yes, the product of these factors that are positive. This left hand side must be positive. How do we satisfy that? 3 regions must work. We must use these 3 regions to test that. How do we do that? Where there is a data between 5 and infinity, we are going to put, where there is, let's put 6. 6 plus 2. Let's test using 6. 6 minus 5. What are we getting there? We are getting positive 8, meaning that this side, this region is positive. What about the middle region? Okay, we are going to look at the values that are between -2 and 5. That is 0. So let's plug 0. 0 plus 2, as well as 0 minus 5 there. That's going to be -10. So this side is going to be negative. So what about this side? So we are going to plug in -3. Let's plug in -3. You can use any value as long as it gives you a correct solution, guys. So it's going to be positive 8. So meaning that this side undergoes a positive region. It's a positive region. It's greater. So let's see. Let's represent this. What about x? X is it's less than -2, or x is greater than 5. So those are your solutions. At the end, those are your solutions, guys, right? Or you can represent this in an interval notation. You can represent this in an interval notation. Let me show you how you can represent this in an interval notation. When you represent this in an interval notation, it's going to be x, it's an element, right? Open the brackets, small brackets, negative infinity is to -2, or 5 is to positive infinity. So that's how you can represent the solution. So there are many ways. Others can use a graph graphically. You can also represent it graphically. Then let's go to the third equation. So even in this one, we need to represent it in a standard form. Let's take 6 to the right and left hand side. It becomes -6 greater than 0. So from here, you can see that the factors of 6 doesn't satisfy the middle term here, because okay, without wasting time, let's see. Does the factors of 6 satisfy the middle term? Definitely, the factors of 6 is 3 times 2, which is they can satisfy it. Yes, they can. Let's see. We know that the factors of 2x squared, it's 2x and x. Factors of 6 is 3 and 2. Let's see whether we are right. 2x times 2x, we are using a method called cross method. 2x times 2 is going to be 4x, and 3 times 2x times 2 is going to be 4x. 3 times x is going to be 3x. For us to get to positive x, we are going to say 4 minus 3x, which will give us x here. So yeah, they are correct. Actually, they are correct. So let's factorize. So it's going to be 2x as well as it's going to be plus, because the last sign is a negative sign. The signs will be different. So we are going to have 2x plus 3 as well as x minus 2, which is greater than 0. Right. So Second step will be look at the critical values, CV. So it's going to be, in this case, you're going to have negative 3 all over 2, or x is equals to 2. So let's represent this. Third step will be representing this in a number line by placing the critical values. So it's going to be negative 3 all over 2, as well as 2. Yes, so remember the undergoing negative infinity, the side undergoing positive infinity. So we are going to look at the products of the factors that are positive in this case. Product of these factors that are positive. 3 regions must satisfy this part, right? How do we do that? We're going to look at the factors that are between 2 and infinity. Let's use 3. Where there is x, let's plug 3. We're going to say 2 times 3 plus 3. Open the bracket, and as well as 3 minus 2, what is that? We are getting positive 9. So this side is going to be positive. It's going to be positive. So what about the middle part? We're going to look at the factors that are between negative 3 and 2. Definitely it's 0. So where there is x, we are going to plug 0 there. Right. Well, we are getting a negative sign, so this region is negative. What about the other side? Let's check the other side. We can use negative 2 since it's negative 1,5. We can use negative 2 to test. Let's test. It's also positive. It's also positive this side. So remember, since it's greater only, it's not greater or equal, so it's greater only. So we are going to use open dot. This will point this side, as well as this will point this side. So lastly, our solution will be x, it's less than negative 3 all over 2, or x, it's greater than 2. Or you can represent it in an interval notation, or using a graphical form. So that's how you can work out inequalities, guys. Hope this video has helped you. Don't forget to subscribe and like and share. Remember, we love you.